a Monte Carlo simulation in Python to help you see where the stock market price might go up. Now, what is Monte Carlo? The Monte Carlo simulation is a method where we model uncertainty by running a certain situation thousands of times with randomness built in instead of predicting one singular outcome. In this project, we're not just modeling one stock, but a whole portfolio. And a portfolio is simply a collection of investments grouped together. For example, my portfolio for today is built up of 40% in the S&P 500, 20% in Apple, 20% in Nvidia, and 20% in Microsoft. Now let's wrap this in Python. The first thing we do in the code is download the historical price data for each of these stocks. We need this because we are going to use past data to estimate how these assets typically behave. Specifically, we are going to calculate something called a return, which measures how much a price changes from one day to the next. And then we transform those into log returns, which are a more mathematically stable way to model compounding growth over time. Once we have these returns, we calculate two very important quantities: the average return and the volatility. The average return tells us on average how much the asset tends to grow each and every day, while the volatility tells us how much it fluctuates around that average. And these two numbers are the foundation of how we will simulate our future. Now, this is where a key concept comes in called geometric Brownian motion. This is the mathematical model we are using to describe how a stock price evolves over time. The idea is that each future price is based on the current price adjusted by a small growth component and a random shock. The growth component comes from average return, and the random shock comes from volatility, which introduces uncertainty into the model. This is why in the code, you see us multiplying the previous price by an exponential function that includes both the average return and a random number drawn from a normal distribution. However, because we are working with a portfolio, we cannot just simulate each stock independently. In real life, stocks move together to some degree, which is called correlation. For example, if the overall market drops, then many other stocks will also drop together. So to capture this, we calculate something called a covariance matrix, and this measures how the returns of different stocks move relative to each other. Then we use a mathematical technique called the Cholesky decomposition to generate random shocks that are not independent but correlated in the same way that the stocks are. Now, if you're curious, Cholesky decomposition works by breaking down the covariance matrix into a lower triangular matrix, which we then multiply by a vector of independent random numbers, so the resulting values become correlated in the exact same way the stocks are. After that, we simulate the future prices of all the stocks over, say, 252 trading days. At each step, we generate new correlated random returns and update each stock accordingly. Then, instead of looking at each stock individually, we calculate the total portfolio value by looking at the simulated prices and multiplying it by the amount of shares that we originally bought. Now, we repeat this process not just once, but hundreds or even thousands of times, where each run represents one future scenario. When we plot all of these outcomes together, we get a visual fan of possible outcomes. Some paths go up, some go down, and most of them stay